Okay, so today we're talking about applications of right triangles. That means like doing a right triangle in real life for something or another. This is like trigonometry is how all the GPS works in your car to get somewhere and so on. So make a right triangle. The first one is really something that isn't new. I just wanted to make sure you were a little warmed up. So where is side A and C? C is the hypotenuse for sure. And the other one can be either. So I'm going to write 53.58, and you should too. I'm going to write opposite angle from that is angle C, and that's how it always works in these triangles. The side, this is like little c over here, so big C is opposite angle. It doesn't matter which one you call which. We'll call that one A, and this one's little a, which is 29.43. This is big B, little b. So we have to find little b and all the angles. Definitely going to want a calculator for this if you don't have one already. Anybody have any ideas of where we should start? Jackson.
Find B.
Find B?
Yeah.
How? Pythagorean theorem. All right, so 29.43 squared plus b squared equals 53.58 squared. Go ahead and square them all.
Wait, so for solving, you want to find all the angles and find...
All the sides. Pythagorean theorem should be so easy at this point, it's almost relaxing. Like your body just does the work and you kind of are just almost brain dead. I mean, I know that you guys haven't been driving for a super long time, but have you gotten to the point where every once in a while when you're driving somewhere, like 5 minutes later, you'll be like, whoa, I don't remember any of that trip.
Yep.
What was I doing, right? And it's because actually it's almost like it's called a road hypnosis. And it is a form of like being so relaxed and so in your routine that your mind can go do other things, but you're still with it. Like if someone walked in front of a vehicle, you would be able to stop. Well, hopefully, yeah.
Wait, so like...
As long as things are going as expected, your brain can actually like almost like go somewhere else for a little while.
When you do go somewhere else, that means that you did everything correctly though?
Yeah.
Like you didn't do anything illegal or run a stoplight or something?
Right.
Oh.
Yeah, but it is kind of freaky to like realize like I don't actually remember the last 3 minutes of me driving. Obviously, I'm here now, and I must have been okay. But yeah, as long as things aren't unexpected, then your body can just do it. So I'm hoping that's kind of what this is starting to feel like, the Pythagorean theorem. Now this part might need a little bit more thinking. So we know what this angle is, that's 90 degrees, but what about this one? How do we find that one out?
45.
No.
No.
It'd be 45 if these were exactly the same, right? But it's not an isosceles triangle.
You're right.
How you guys doing? You remember? Are you alive? So, ka,
Oh.
tawa. All right, somebody raise their hand who wants to be brave. Come on. Be brave.
Where's Carl?
I know, where's Kyle? Emma, what two sides do you want to use? There's so many ways to do this problem. Which two sides would you like to use?
A and B.
and B. Okay, so this is the adjacent side, and this is the opposite side compared to that angle that we're talking about. So what are we going to use, Emma? Sine, cosine, or tangent? Tangent. So the tangent of theta equals, let's see, OA. O goes on top, 44.78 divided by 29.43. And do you remember what special thing you have to push, Emma, to get the angle? Anybody remember what special button you have to push to be able to get an angle rather than a side? It is going to be tangent, but not quite just regular tangent.
No, it's the inverse tangent.
Inverse tangent. All right, so everybody hit second inverse tangent. You don't even have to do you can have the calculator do the math for you. You can just write inverse tangent 44.78 divided by 29.43.
Why is it inverse?
Because you're trying to find the angle. If you were trying to find a side, you would just use the regular thing, which gives us about 56.7 about. Now, you could have used lots of other things. You definitely had to use an inverse, whatever it was, to find the angle. But Emma, the only reason why Emma picked the opposite side and the adjacent side, so we had to use tangent compared to that one. But if she had said, I want to use the hypotenuse and the adjacent side, then we would have used cosine. You know, it just depends on which two sides you use. Doesn't matter. You can pick any two as long as you connect the right name to the right relationship. Now, we could do that again if you wanted to, or we could do something far easier to find the last side angle. Anybody know?
You add it up and then minus it by 180.
Right. So 180 minus 90 is 90, and then you have to take 90 minus 56.7, which is what? 33.3 degrees, about. All right, how was that? I imagine that the first one was very much like highway hypnosis, and that the second one required your brain actually to activate for a little bit. I'm so sorry. Raise your hand if you're like, whew, I'm really happy. Just raise your hand halfway if you're like, good thing we just did that because my brain was not working.
I just need
Sweet.
to like the reminder.
Reminders are good. Okay, that's perfect. Next up, this is more like what actual trigonometry problems look like. There's actually a cool problem in your homework where they didn't know the height. This is true story. They didn't know the height of Mount Everest because nobody had ever climbed it. And so they had to use trigonometry to find out how tall it was. And because nobody had actually made it before. You'll see. It's pretty easy. Basically, you you stand on a mountain peak. Okay, so imagine there's here's Mount Everest. Looks exactly like that, right? Perfect, exactly like that. There's like another mountain peak that's pretty close to it. So they knew this distance. And people had been to the top of this one. And they knew how tall this one was. All right, so they have like this number. And they have this number. And so then they knew this angle because they could hold a compass, like they do when they're doing construction, right? Where they can hold it up and see what angle it would be to go to something. And since they knew how far away the center of this mountain was from the center of this mountain, and they knew this angle, they could figure out that height. And then they took the height of the other mountain plus the height of the new thing and found how tall Mount Everest was.
But how do you even see the top?
How do you see the top of Mount Everest?
Aren't there clouds there?
It depends on how clear the day is. But yeah, I mean, there's lots of times there aren't clouds in the sky. Okay, at a point A, 123 feet. Now, the hardest part, I think, about all of these problems is honestly drawing a picture, okay? Which is why I left all the pictures out, why we're drawing all of them together. Okay, so we've got a flagpole, so draw an amazing flagpole, please. I don't care, you can make your flag any kind of flag you want. We're assuming anytime they're talking about a pole or they're talking about something like that, that it is going to be a 90-degree angle from the ground. I realize that not everybody actually has that This is 123 feet. Now this is point A. Everybody okay with the picture I drew so far? Got point A, it's 123 feet from the base of a flagpole.